Hello to everyone. I wish you a very good day. Today I will be talking about a new alliance, World Alliance on Digitalization for Disaster and Emergency Management. The alliance was supported by the TÜBİTAK BİDE program 2232, International Fellowship for Outstanding Researchers. And I am Mehmet Akşit, coordinator of the alliance. This is the table of contents. First, we will talk about disaster types and disaster management system in general. Then I will give information about the alliance, in short, WADDEM, activities of WADDEM. Then I will give also the conclusions in the end. Let's talk about disaster types and disaster management systems. Well, disasters can be caused by natural, technological, or human reasons. Natural disasters can be of course, different kind, from tsunami to earthquake, and so forth. And technological disasters can be caused, for example, by explosions of factories and these kind of things. And human-caused disasters can be, for example, caused by a terrorist attack. In the literature, when you look at disaster management, you will see such descriptions. So you may classify activities related to this topic, pre-disaster and post-disaster activities. In pre-disaster activities, you try to prepare yourself and you want to predict when disasters could happen and what could happen if a disaster happens, and so forth. So these are all kind of activities belong to a pre-disaster phase. And when a disaster occurs, most of the time experts execute certain procedures. Experts most of the time are located in some dedicated places like control rooms. They try to identify what has happened and they try to assess the situation. They try to understand. Of course, in some ways, they have to cope with it. While coping with a particular disaster, they may develop strategies, and most of the time, of course, they have to apply so-called recovery procedures. This is another model, so-called disaster management life cycle model. It's actually similar to the previous slide. Here we have a life cycle. It's divided into 3 phases: before event, during event, after event. And before event, you have to apply all kind of risk reduction techniques. You want to prevent yourself, again, prepare yourself. And when a disaster happens, you have to respond to it. And this could be also relief and recovery operations, followed by immediate response. Well, in general, actions to be taken depend largely on the disaster kind. So if it is a wildfire or a tsunami or an earthquake, of course, these are all different kind of disasters. In the literature, when you look at the publications and efforts and the research, most risk reduction techniques focus on the before event phase. Response operations are also called rescue and intervention operations. Well, let's look at the state of the art as we observe today. First of all, what you want to do is you want to understand the effect of a disaster. For example, you may use drones. You may have all kind of ground-based data sources. You may place sensors at different locations, security cameras you may have. And of course, there may be also people on site, and you may receive responses. from different kind of people. And all these information you can store in a database, can be also a cloud, and information is retrieved and displayed and visualized so that experts can look at these and then decide what to do. And experts give orders to so-called task forces. And of course, there are also logistics centers. Task forces can be different. For example, rescue operations, firefighter teams, security teams, repair teams, and of course, medical personnel. In running all these processes, different kinds of software technologies are involved. While you are gathering information, drones and sensors, all these have their own software and plus IoT networks and also communication networks. You have to store software related to big data and clouds, analysis, visualization, and command control systems for giving orders and tracking the aid operations. Logistics centers also, they have their own software to, of course, arrange the parts, spare parts, and so forth. Well, you may ask question, then what is missing with today's disaster management systems? Here is a list. We will explain these in detail later in this presentation. Lack of end-to-end traceability and process support for command and control. Weak or absence of automated demand generation and optimal allocation of resources. Lack of key performance indicators. Lack of mechanisms to optimize the aid operations online. And lack of digital ecosystem platforms. So WADDEM's claim is that WADDEM says that disaster management is a resource management problem and digitalization is needed to its fullest extent. If you look at this flow of running of procedures, you detect what has happened, and in the end, you have to allocate resources to the disaster areas. So it's really, from all perspectives, it's a resource management problem. This is the claim of WADDEM. Now I want to give information about the Alliance. Well, WADDEM will cover disaster caused by all types of hazards, including natural, technological, and human. The objectives as defined by WADDEM are identified by extensive field study and problem analysis. So we did not imagine these problems on the table, or we really interviewed people who are involved in disaster management and formulated requirements related to, of course, the problems observed. Requirements we formulated from 4 different viewpoints: disaster management viewpoint, system architecture viewpoint, software design, and quality viewpoint. And we formulated these requirements as questionnaire. We discussed with the experts, and experts said all are needed. Since it's quite a complex problem, what do we do then? We want to prioritize these requirements, and this report actually did that, or gave a summary of the prioritization. And following to that, we carried out a synthesis study, meaning that, okay, these are the requirements, we want to fulfill them, therefore we need to build a digital system what kind of skills and competences we need to build such a system. Well, the alliance distinguishes itself in the following ways. First, process automation for command and control, digital ecosystem platform, the adopts principle, the role of social capital, and disaster and emergency resilient economies and industries. We claim that all these together as a package is a new paradigm in disaster and emergency management. I will explain these one by one. Well, process automation for command and control. The Alliance focuses on novel techniques in automating disaster and emergency management processes and traceability related to that, of course, for command and control in the broader sense. So for each disaster instance, for each victim, for each rescue operation, for each source used, we want to actually track and control. So here we see, again, symbolic representation. Command and control should be supported digitally from begin to end for all kinds of relevant aspects of disaster management. Secondly, we want to develop and, of course, define standards for digital ecosystem platforms for the purpose of disaster management. What does it mean? The Alliance undertakes a digital ecosystem engineering approach. So what does it mean? If you look at many applications, software applications, they are focused, specialized for one purpose. It is therefore very difficult to reuse many aspects of the platform. So therefore, instead of targeting disaster-specific applications, research and development, and I must say also standardization activities are first carried out in the specification and implementation of a digital ecosystem platform, where the disaster-specific automation processes can be installed on the platform when needed. I will show this more symbolically. So this part symbolically shows the companies developing applications. They provide their applications and they are available, let's say, at the application store. Of course, to do that, they must fulfill certain requirements of the platform. The application store is installed on the top of the platform. So there is a platform owner, and users of the disaster and emergency management system retrieve or execute these applications to fulfill their tasks, like, for example, running disaster management processes. This is, of course, a quite common approach. We use most mobile phone providers, almost all of them, provide some sort of an app store. And this approach, what we want to carry out, is very similar to that. And the third, we want to discuss about the adopts principle. And there are some 6 items: awareness, demand generation, optimization of allocation of resources to demands, performance of the processes, tracking, utilization of the allocated resources, and simulation of disaster situations to define, learn, and optimize the processes. And we will discuss these also one by one. So awareness and situation detection. I will explain this with the help of an example. So different kind of disasters may happen. Assume that an earthquake has happened. And what we want to do is, with the use of all kind of data sources, we want to detect what has happened. And in our system, we use all kinds of digitalization techniques to do that. Here is, for example, an example table. The first column represents the unique identifiers of each disaster instance, meaning that we give a unique identifier to each disaster instance. For example, this one is 9. What has happened? Collapse. Other things may also happen, of course, after an earthquake, like fires, like landslides, and so forth. Then we try to determine, by means of digital techniques, the intensity of a particular disaster instance. Then the location and what has happened, what is the effect. So it may affect, for example, networks, electricity, gas, water networks, residences, bridges, finance center, meaning banks here. And we try to also determine the number of persons involved. So this is a very important phase, of course, and this is what we call awareness and situation detection. In discovering such information, we use certain objectives, and mainly 4 objectives. First, detect the damage with highest precision. Second, detect the location of human beings or living creatures with highest precision. Accomplish the goals with the lowest possible cost. Accomplish the goals in the least possible time. These are the 4 objectives. Of course, they may conflict with each other, so you have to find a balance. Secondly, a very important aspect of our approach, which distinguishes itself from the other approaches, is demand generation. What does it mean? Demand lists are automatically inferred for the necessary resources so that aid operations can be executed efficiently and effectively. This table was shown in the previous slide, and based on this table, we provide this table actually to so-called demand generation system, and demand generation system calculates the necessary resources to the problems, to address the problems caused by this disaster. Here, for example, disaster instance 9 requires a single firefighter team, 2 medical teams, 4 repair teams, 3 rescue teams, and also 3 teams of security forces. The next step is optimization. Again, we will give an example. What is then the optimization phase? We have demands. We have just seen an example for that. And then we have resources. What we want to do is that the available resources are optimally assigned to the inferred demands and on time. In case of insufficient resources, you may apply various strategies like prioritization, like trade-off. For example, you don't allocate 100% of the resources, but 80%. You may also do dynamic selection. Depending on the situation, you may select the best strategy on time, online, or mixture of these. Okay, let's look at the example. These are, for example, the required resources. And these are the available resources shown symbolically. We provide these information to the scheduler and optimizer. Scheduler actually tries to compute or allocate the resources in the minimal time. It is not really an optimization process. It's a functional process. So something can be, a list can be either schedulable or not schedulable. But if you annotate certain information. You may also turn this into an optimization problem. For example, in case of prioritization trade-off, it can turn into an optimization problem. And in the end, you try to compute and schedule the allocation of resources to the demands. Here is an example. This is a scattered plot of the end time of the scheduled resources for the emergency instances that are detected. As you can see, it can be a very complex process to do that. In general, in a large disaster case, human brains are not capable of doing these kind of allocations in the best way. Therefore, we need digitization. Performance is also important. What we want to define and actually measure are the performance indicators. The performance indicators of operations are defined formally, or should be defined formally, so that desired objectives can be specified and measured. Accordingly, ongoing operations can be monitored online, and in case of deviations from the desired performance values, corrective actions can be executed. Here we mainly focus on the performance aspects. For example, a disaster has occurred and the task forces are on their way. Some of them has already, they are at the location, and we gather information. We monitor all these 8 operations, and we have previously defined all kind of performance formulas, and online continuously we calculate the performance of each 8 activity. Related to that is the tracking and control phase. This phase includes both monitoring, evaluation, and controlling actions of the ongoing activities, as well as coordination among the 8 operations. Again, we need monitoring. Then we can compare the current situation with the planned situation, and we may take corrective actions if needed. Simulation is also important. What does it mean, simulation? Why do we do that? First of all, to determine the effect of a large set of prospective disaster scenarios. Of course, we may have many different kinds of disasters. We may experience different kinds of disasters. Every disaster can be a surprise. Therefore, we have to try, in our case, in an automated or digitized way, different kinds of disaster scenarios. To determine the effectiveness and efficiency of the disaster and emergency ecosystem platform, and to evaluate the necessary quantity of resources and to optimize the location of logistic centers, simulation environments and techniques must be researched, designed, and implemented. Even in times when no disasters are experienced, triggered by the simulated disaster scenarios, the ecosystem platform must be continuously operational so that it can be optimized using online machine learning techniques. Let me illustrate that. Normally, when a disaster occurs, we try to gather information from many data sources. But of course, we want to prepare ourselves before a disaster occurs. Therefore, we need simulation activities. Here we symbolically show that. Here is an example, for example, a floating simulation. Since we cannot wait to experience such a disaster, we have to prepare ourselves before a disaster occurs. We use this simulation phase. Electronically, we generate signals as if this real disaster has happened. We fed this information, for example, to the ecosystem. In this case, first demand generation system, scheduler and optimizer, and so forth. So that, as we have listed on the left-hand side, we can optimize our system through machine learning techniques. Other kind of activities are social capital. What does it mean? The role of social capital in disaster preparedness and intervention. We want to carry out research activities on this topic. What does social capital mean? Social capital can be defined as the value of interrelationships between people who work or live together, and the knowledge and skills that they have and they share. So research activities on this topic, we plan to carry out in 3 possible ways. First, the role of richer social capital in disaster preparedness and intervention. What does it mean? So what does it mean, richer social capital from the disaster management perspective? Secondly, also, it's important that, of course, in disaster management, you have authorities, the formal authorities, governmental authorities. So how to coordinate the responsibilities and the authorities of governmental and social capital roles in meaningful disaster scenarios. They have to work together. And how do we provide that? Finally, we want to, of course, have richer social capital. The question is, what are the methodological policies to increase wealth in social capital from the perspective of disaster management? Finally, we do research on economics for disaster prevention and preparedness. What does it mean? Well, there are also here 3 important goals. With the use of digitalization techniques, we want to create economical and industrial infrastructure. A, can withstand major disasters and emergency conditions. B, reorganize and optimize the capabilities in creating new resources and products in minimizing the negative effects. And C, guiding policymakers and practitioners to make smart investment that can strengthen disaster resilience. Now, let's look at the activities of the Alliance WADDEM. The first kind of activities can be seen as problem analysis, research, and cooperation. And here are the activities which we may carry out and which we carry out. First, starting from the human-centered disaster scenarios, formulate the areas where the current disaster and emergency management system fall short of the needs. So we have a mission-oriented, problem-driven approach. Second, elaborate on the digital solution domains, because we want to apply digitalization techniques, and define the areas of technological research in harmony with psychological, sociological, economical, and industrial considerations. These are also inconsistent with the previous items which I have mentioned. Third, we want to coordinate with the governmental agencies and work out strategies in bringing the importance of digitalization of disaster and emergency management issues high on the political agenda. Carry out lobbying activities in creating national and international granting programs. Fourth, initiate, support, and collaborate within research and education activities. To this aim, create opportunities for mutual visits and joint activities among the members of the Alliance. What do we mean by that? We organize workshops, conferences, special issues in journals, publish and disseminate the generated knowledge as manifestos, standards, and ecosystem infrastructures, and research contributions in the relevant public media. Define professional certification criteria based on offered training plans and accredited evaluation bodies in various roles. For example, 8 personnel decision-making managers, technologists, and entrepreneurs. Standardization activities are also very important. Here is a long list. Standardization of disaster and emergency data. It's very important. Data can be used in improving situation awareness and data fusion. And it must be conveniently possible. I must say, however, that most people talk about standardization for disaster management only from this perspective. However, if you apply digitalization in the broadest sense, you must standardize many more aspects of disaster management. For example, standardization of simulation activities. Simulation is a complex process you want to share. The required disaster management cases and scenarios with special dimensions can be then reused, extended, and shared if we can standardize. Well, we have to implement these systems in a distributed way. Most of these systems have systems of systems infrastructure, cooperating distributed nodes. Cooperation among distributed computing nodes can be facilitated for the common goal if we have standards. Digital ecosystem and application stores, they must be standardized as well, so that applications developed by different parties can utilize the disaster and emergency management platform effectively. Models must be standardized as well. What kind of models? For example, disasters and emergencies, GIS models, events, digital twins, demands and resources. We have to standardize them so that independent developed models can be easily reused. Performance models must be standardized as well so that independently developed systems can be optimized for the common performance goals. Models for tracking and coordination must be also standardized so that independently developed and managed aid operations can be tracked and accordingly integrated. Conclusions. WADDEM will cover disaster caused by all types of hazards, including natural, technological, and human. We claim that WADDEM provides a conceptual paradigm shift in disaster and emergency management by process automation, digital ecosystem platform, the ADOPS principle, and research activities on the role of social capital in disaster preparedness and intervention, and economics for disaster prevention and preparedness. WADDEM is complementary to current research activities on disaster risk reduction and management. But we must remember that disaster and emergency management systems are long-living systems. So we really have to invest in these systems. We must consider such investment for a long term. Each year we have to go forward and systems must be improved through simulation, through machine learning, and all these kind of techniques. So it requires continuous investment, research and development activities. Thank you for your